Alright, in this lesson we're looking at some more examples of converting standard form, complex numbers, into polar form. So I've got an example here, z equals -2, take away 3i. So remember, our first step is always to draw a diagram. -2, -3 on the imaginary. So our complex number is down here. Here's z. So to work out we want z equals r cis theta. That's what we're trying to work out. So we need r and we need theta. So we work out r. R is easy. It's the square root of, make a right angled triangle out of it with the horizontal axis. Don't draw your line across here. So we make a right angled triangle out of it, and we know that this length is 3. Forget the fact that it's negative, and this length is 2. The length is actually 2. So it's the square root of 3 squared plus 2 squared, which will be the square root of 9 plus 4, which is the square root of 13, which doesn't simplify. So we could write that as a decimal, but I'm just going to leave it as a insert form. The next thing we need to do is work out the argument. Now, to work out the argument, first of all, we work out the angle to the horizontal. We work out this angle in here. So theta is equal to the tan inverse of opposite over adjacent, 3 over 2. Forget the fact that you've got positive or negative signs. Just do it as the positive. 3 over 2, opposite over adjacent. Now, in other examples that I did, these worked out to be exact ratios with pi. But in this case, we're actually going to need to work out the tan inverse of 3 divided by 2 equals 0.983 radians. Okay, so it's nearly 1 radian. A radian is about 57 degrees, so that gives you an approximate picture in your mind as to the size of this angle. Okay, now what all that tells us is that that angle there is 0.983 radians. But what is the argument? What is argz? Argz, remember, always has to be measured from the positive real axis, and I've got to get to my complex number the shortest direction, the shortest route. The shortest route, is it going to be going around the circle there, or is it going to be coming back this way? Certainly this way is going to be shorter. So that's going to be my argument. Now, how do I work this out? I know it's going to be a negative number because I'm measuring backwards. If I came backwards all the way to here, back to the negative axis here, I would be back at minus pi. Okay, remember pi, and since we're working in decimals, negative pi is like minus 3.14. Okay, pi is 3.14, 159, whatever it is. So negative pi would be negative 3.14. So argz, I'm not coming all the way back to negative pi. I'm not coming all the way back to negative 3.14 because this angle is 0.983 in itself. So I'm only coming back negative 3.14159, but I'm not going that far back. I've got to add on that bit in the middle, the 0.983. So in my calculator I can go negative pi plus the 0.983. Okay, we can just use pi in the calculator, we don't need those decimals. So we've got negative 2.159. Negative 2.159 radians is this. negative 2.159. And if you add the 2.159 plus the 0.983, you'll get pi, or negative pi. Therefore, Z, my complex number, r cis theta is going to be root 13 cis negative 2.159. So just emphasizing here, the angle that you work out using your tan, your trig function here, is just your angle to the horizontal axis. You then need to convert it to an argument. And an argument is always measured from the positive real axis in the shortest route to get there. In other words, either up to pi or back to minus pi. Alright, we'll do one more example. Z equals root 3 minus 2i. I've deliberately chosen this example to revise some basics that you perhaps should know. Okay, first step, draw a diagram. Root 3 on the real axis. Notice I don't care about the scale. All I know is it's somewhere up here on the real axis. Negative 2i, somewhere on the imaginary axis down below. There it is. Now we need to work out mod z, or r. To do that, we need a right angle triangle. Let's make one. Remember, we always make our triangle with the real axis. We can put in our angle theta there. We'll use that, work that out in a minute. Okay, so mod z, or r, same thing, is the square root of this side squared, which is just root 3 squared, and this side length is 2. Forget the fact that it's negative. Equals the square root of root 3 squared is just 3, plus 2 squared is 4, so square root of 7. In other words, this length is root 7. We could work it out as a decimal, but let's leave it as an insert form. Now we want to work out the angle. Theta equals the tan inverse of opposite over adjacent. Tan inverse of 2 over root 3 equals, so come to your calculator, tan inverse 2 divided by square root 3.857. Now in this case, this angle here is 0.857, therefore we need to convert it to an argument. Therefore argz equals, it has to be measured from this axis with direction given. What's the quickest way of getting to here? It's not going all the way around the circle, it's just going to be coming backwards, so we've got a negative angle, so it's going to be negative 0.857. Therefore z, our complex number, equals r cis negative 0.857. Alright, I said that I was going to be revising something else that you perhaps should know, but that question I did it the wrong way around, but it was still a good question to do anyway. Alright, in the next lesson we'll revise converting from, we'll do some examples converting from polar form to standard form the other way.